Based on this Hall effect, we can design the sensors. They are known as the Hall sensors, and they can be used to detect the magnetic field position and displacement of an object. Okay, the Hall effect is based on the interaction between moving electrical carriers and an external magnetic field. Suppose we have an external magnetic field and the charged particles are moving in this external magnetic field. So because of this magnetic fields, they deviates from their paths. Okay, so when they deviates from their path and moving charge constitute the flow of current. So when they deviates from their path, definitely there will be deviation in the flow of the current. So in fact, Hall effect is based on this phenomenon. So when an electron moves through a magnetic field, upon it acts as a sideway force, and that force is a vector quantity given by QVB, where F is the vector quantity, that is force, Q is the electronic charge, V is the speed of the electron, and capital B is the magnetic field. So all are the vectors. They have the magnitude as well as the direction. Now to explain that, let us assume that the electrons move inside a flat conductive strip that is placed in magnetic field as shown in this figure. This is the conductive magnetic field. Okay, magnetic sheet. It is placed in the magnetic field. Magnetic field line of forces are shown here like this, straight lines, and represent the magnetic field is represented as B. This the electric sheets, the two sides of this sheet, they are connected with the external electric field. So this is with positive terminal of battery, and this is with negative terminal. And this sheet, because it will have some resistance, so what will happen? Some current start flowing from positive direction to negative direction. And the direction of electrons means its speed we can represent in this direction, from this to this. Suppose there is no magnetic field, what happens? The V direction will be from this bottom plate to the top plate in this way, from upward direction. But because of that magnetic field, what happens? So see, the strip has two additional contacts as its left and right sides, which are connected to a voltmeter to measure this, to see the Hall effect. These two sides, they are connected to electric voltage source, and these two sides are connected to a what? This is the movement coil that is showing some fluctuation in electric field. Okay, so this is connected with this voltmeter. These two plates. Two other sides, as I said, plate at the upper and lower ends of the strip, they are connected with some electric fields. Okay. So because of that, they are connected with some electric source. So because of that, an electric current will flow from the top to bottom, means in this direction. So this is the direction of current flow. The upward direction, in this direction, the electrons will flow. So this is representing the speed of the electron. Correct? Now what happens if no magnetic field is present? Nothing will happen. The electrons will flow in this direction. The speed of electron will be from lower plate to upper plate, and the current direction will be from upper to lower. This will be the same. But because of the existence of this magnetic field, what happens? The deflecting force shift moving electrons toward the right side of the plate. Means this is left side, this is right side. So when the electrons are moving in this direction with velocity or speed v, they will be deflected, deviated from its path. And this deviation will be toward the right side of this plate. Now, when more electrons are moving towards this direction as compared to this, what will happen? This plate may be assumed as more positively placed, and this is less positively, correct? Because movement of electrons uh, gets deflected towards this plate. So this will become negatively charged. This will become positively charged. If a voltage meter is connected between these two plates, definitely voltage meter like a galvanometer. Okay, so there will be deflection in the position of the galvanometer. So this will indicate a voltage difference that exists between these two plates. Okay, so that voltage difference is called the transverse Hall potential difference VH. So by measuring that, we can design a sensor based on the Hall effect. So this is the Hall effect. What is Hall effect? As shown with this equation, when electrons move through a magnetic field, there exists a force. Okay, and because of that, they deviate their path. They deviated from their original path. Okay, and that's why these two plates they assume the different potential difference. Earlier there was no potential difference. Okay, now they are assuming that this becomes more negative, this is positive. So a potential gradient exists between these plates and that can be measured. So this is what the Hall effect, and based on that effect we can design a sensor. And the sign of amplitude of this potential depends on both magnitude and direction of magnetic field and electric current. Means how much potential is developed and in which direction, whether this is positive or this or opposite. That depends on the magnitude of this B as well as the current and its direction. So based on that, we can define Hall sensor. So many Hall effect sensors are fabricated from silicon and fall into two general categories: the basic sensors and the integrated sensors. Integrated sensor means they have some other components to sense something, then provide signal conditioning and other things. The other material used for element fabrication include INSB, INAS, germanium arsenide, okay, etc. We have one example of this Hall effect sensor. Uh, it is UGN 365K, and it is manufactured by a company known as Spargu. So with this sensor, we can sense the Hall effect, and we can uh, use this sensor for different purposes. As I mentioned here, what we can sense with this, the position, magnetic field, and displacement of an object. So how much displacement is there? Means what is the position and how much magnetic field exists between that. Okay, so we can also design the Hall effect sensors with the sensing principle that is related to Hall effect.